Welcome to the lesson on casting. Upon completion of this lesson, learners will be able to understand and explain the fundamental aspects of casting and manufacturing. Learners will be able to define the casting production process used in manufacturing and articulate the sequential steps involved. They will be capable of identifying various types of casting molds and their specific applications in the manufacturing process. Learners will demonstrate knowledge of different casting methods, including sand casting, die casting, and investment casting, along with their respective advantages and disadvantages in manufacturing applications. Learners will also be able to recognize the practical applications of casting methods in the electric vehicle industry. Children often build sandcastles with wet sand during vacations at the beach. Building sandcastles involves building the base of the castle, compressing wet sand into a bucket, and putting the compressed sand on top of the base to create a pointed shape on the top of the castle. The art of using buckets and molds to build sandcastles is similar to the manufacturing process called casting. Casting is when molten metal is solidified in a mold to create a desired shape. The process begins by melting the metal into a liquid state. Once liquefied, the molten metal is carefully poured into a prepared mold that has been shaped to match the desired final product. The metal then undergoes a crucial solidification process as it cools within the mold, transitioning from its liquid state to form the intended cast metal shape. After complete solidification, the mold is removed from around the metal casting. Finally, the cast piece undergoes a thorough inspection to check for imperfections or impurities, and appropriate finishing processes are applied to achieve the desired final product specifications. Let us now discuss the two types of casting molds, metal molds and sand molds. When using metal molds, the molten metal is poured into the mold with the help of gravity, vacuum pressure, low pressure, or high pressure. The molten metal in the mold solidifies after it cools to produce the desired cast metal shape. The solidification process should be performed carefully to avoid cracks, breaking, or porosity in the metal. Solidification is one of the most important steps in the casting process because the properties of the final product are set during this step. Problems during solidification can cause product defects such as porosity and shrinkage. The mold should be removed from the metal after it solidifies, and this process is known as mold removal. The choice of material for each mold must include verification that it will not mix with the molten metal. After the casting process is complete, the final product is inspected to check for any imperfections, impurities, and finishing. The products produced by casting can be as small as screws or nuts and as large as turbine blades. Automobile parts such as motor housings, transmission housing, or fuel tanks requiring a hollow interior can be made easily using the casting process. When using sand molds, the casting process starts with the identification and construction of the pattern. The pattern will be a rough sketch of the final casting. The molding material is then packed around the pattern, and then the pattern is removed. The entire mold is placed in a rigid wooden frame called the flask. In two-part casting, the top part of the flask is known as the cope, and bottom part is known as the drag. If the casting product has some internal features like groves or holes, these features are provided by a metal or sand core. The molten metal is poured into the mold cavity through a pouring cup and a sprue to channel the flow of the molten metal. The sprue controls the pouring path of the molten metal and helps to build the necessary pressure on the fluid so that air in the pouring path will be removed. As described earlier, the term casting describes the process of creating an object using a mold. This term, casting, is also used to describe the product that is formed after the cool-down process. There are three main methods used for casting processes, including sand casting, die casting, and investment casting. We will discuss these methods in greater detail in the upcoming slides. Sand casting is a process where molten metal is poured into a sand mold to form components. The process begins with creating the mold by carefully packing sand around a pattern, which is then removed to leave a cavity that will be filled with molten metal. This versatile manufacturing method is ideal for producing parts with complex shapes or smaller quantities, offering significant design flexibility to manufacturers. The process can accommodate a variety of common materials, including iron, steel, and aluminum. Due to its adaptability and cost-effectiveness, sand casting finds widespread application across various industries, including automotive manufacturing, machinery production, and construction. Sand casting presents a range of advantages and disadvantages that make it suitable for specific manufacturing scenarios. On the positive side, it offers low tooling and setup costs while enabling the production of very large parts using a wide range of metals. The process is particularly advantageous for prototypes and small production runs, allowing for complex internal geometries and easy pattern modifications with no size limitations. However, these benefits are counterbalanced by several drawbacks. The process results in a rough surface finish and poor dimensional accuracy while operating at a slow production rate. It is labor-intensive, and each sand mold can only be used once before being destroyed. The finished parts often require additional machining. The process has limitations when it comes to thin sections, and it typically results in higher material waste compared to other casting methods. The second method is called die casting, a process of injecting molten metal under high pressure into a steel mold to produce precise, high-quality components. This manufacturing technique is specifically designed for producing large volumes of parts with complex shapes, making it highly efficient for mass production. The process delivers excellent dimensional accuracy and smooth surface finishes, making it ideal for components that require minimal post-processing. Die casting typically works with lightweight metals such as aluminum, zinc, and magnesium, enabling the production of durable yet lightweight components. Due to these characteristics, die casting has become a preferred method in industries like automotive manufacturing and electronics, where high-volume production of precise, lightweight parts is essential. Here are the advantages and disadvantages of die casting. On the positive side, it provides an excellent surface finish and high dimensional accuracy while maintaining high production rates. The process can produce parts with thin walls ranging from 0.5 to 2.5 millimeters and delivers good mechanical properties in the finished products. One of its key benefits is that it requires minimal post-processing and proves cost-effective for high-volume production. However, die casting also comes with several disadvantages that must be considered. The process requires high tooling and equipment costs and is limited to smaller parts and lower melting point metals. Making design changes can be expensive, and the process is not suitable for small production runs. Manufacturers must deal with die wear issues, potential porosity problems in the finished parts, and high maintenance costs for the equipment and tooling. The third method, investment casting, is a process where molten metal is poured into an expendable ceramic mold formed by using a wax pattern. This sophisticated manufacturing method is capable of producing highly detailed complex parts with exceptional accuracy, though it comes at a higher cost compared to other casting methods. The process is versatile and allows for the use of a wide range of materials, including stainless steel, aluminum, and brass. The manufacturing process follows several key steps. It begins with creating the pattern, followed by mounting the wax patterns and creating the tree structure. Next, the mold shell is created around the wax assembly, after which the wax is removed through a melting process. Once the mold is prepared, the chosen metal is melted and cast into the ceramic shell. The process concludes with final operations such as removing the ceramic shell, cutting parts from the tree, and performing any necessary finishing operations to achieve the desired specifications. Investment casting presents a range of advantages and disadvantages in manufacturing. Among its advantages, the process delivers an excellent surface finish and very high dimensional accuracy while enabling the creation of complex shapes. It excels in detail reproduction and can work with a wide range of metals. The process allows for thin walls down to 0.6 millimeters and is particularly well suited for complex small parts, with the added benefit of requiring minimal draft angles. However, these advantages come with significant drawbacks. Investment casting has the highest cost per unit among casting methods and faces notable size limitations. The process operates at a slower production rate and is labor-intensive, requiring a complex setup process. It is primarily limited to smaller parts, involves high material costs, and the pattern costs can be substantial. Casting is widely used to produce precise parts for various industries, including electric vehicle manufacturing. For example, motor housings are cast to provide solid enclosures for electric motors. Battery housings are cast to protect battery cells, ensuring safety and durability. Chassis parts, like cross members and brackets, are cast to provide the vehicle frame's structural support and rigidity. Cooling plates are cast to manage heat and maintain the performance of the battery and motor. Suspension parts, such as control arms and knuckles, are cast for strength, allowing them to withstand the stresses of the vehicle's suspension system. In summary, casting is a manufacturing process that involves turning molten metal into a solid of the desired shape using a mold, with two primary types of molds being metal molds and sand molds. The manufacturing industry employs three main casting methods: sand casting, die casting, and investment casting, each with its specific advantages and applications. The versatility of casting processes is demonstrated by their ability to produce a wide range of products, from small items like screws and jewelry to larger automotive components such as motor casings, battery housings, and chassis components in the electric vehicle industry. Thank you.